Hello and welcome to IB Enable Learning Center with Mr. Tai. In this video, I would like to help you and explain how to solve this problem. This is a question number 13 about complex number. An electric circuit has two power sources. The voltage V1 provided by the first power source at the time t is modeled by V1 is a real part of 2e to the power 3ti. The voltage V2 provided by the second power source is modeled by V2 equal the real part of 5e to the power 3t plus 4i. The total voltage in the circuit Vt is given by the sum V1 and V2. Question A. Find expression for Vt in the form A times cosine Bt plus C, where A, B, and C are real constants. And question B. Hence, write down the maximum voltage in the circuit. Firstly, I would like to explain to you why the voltage can be represented in form of a complex number. We know that a complex number can be represented, for example, z. A complex number z has two parts, a, which is the real part, and bi, which is the imaginary part. Okay, and we can represent a here as a cosine of a phi, which is argument of the complex number, and b here, with the modulus r, multiplied with the modulus r in front of it. Similarly, b is the modulus r multiplied with sine of the argument and then times the imaginary number I. Therefore, this voltage V1 and V2 can be represented as the real part. The real part means this thing, r times cosine of phi. For example, V1 can be represented as V1 maximum multiplied with cosine of this, the real part of this complex number. The number 2 here is the modulus. So V1 should be that thing, the modulus 2, and the thing inside is the 3t. 3t is the argument, where t is the variable, the time, which means that the voltage varies like this as a cosine function, starting from maximum and decrease to 0 and goes up and like this. Okay, there. And similarly for V2, again the maximum here is 2 volt, and this is the cosine function with the variable t on the horizontal axis. Okay, to find the total voltage, the sum of the two alternating current V1 and V2, there are two methods. The first method is that we simply just need to add the two real part of the two complex number in the exponent form like this, which means we add r times, let me write from the beginning. V1 plus V2 is equal to 2. Just take the real part. Anyway. Okay, that's the real part of the two complex number added together, e to the power up to 3ti and plus 5 e to the power of 3t plus 4i. There, only the real part of this sum of two complex number. Okay, the e to the power 3 plus 4t here can be written as e to the power 3t I, and then multiply with e to the power 4i. Okay, therefore this thing, e to the power ti, is the common factor of the two complex number. Therefore, I can bring that common factor outside here, e to the power of 3ti, and the inside e2 times e to the power 0, which is 1, and then plus 5 e to the power 4i. Okay, and here in the front of it we write the real part of its complex number. Now, to add these two complex number, we simply just need to use the calculator, which is allowed in Math AI XL. Okay, use a complex number calculator. Firstly, I would like to remind you about the setup to represent a complex number in different form. When we open the calculator, in this case Casio FX 9A660, I want to set up the the form of a complex number as a polar form or trigonomical form or exponent form, huh? So click here, shift and open the setup menu, setup, and then scroll down, hit the arrow here to go down to the complex number here. And here we have three options to display the complex number. We are adding the two exponential form, the exponential, the form of the two complex number in exponential form. So I will choose the third one here, which display the modulus and the argument in the exponent form. Click F3 here, huh, to choose the exponent form there, and then execute here, execute. Now I just need to enter the sum of the two complex number inside the round bracket, which is 2 plus 5 e, huh? The e here, shift, choose e and to the power of 4, and then the imaginary number, shift the imaginary number I here, there, oops, I there, and then hit execute to get the result. The number 3.99 here, 3.99 is the modulus, and the value minus 1.894 is the argument, okay, which means the sum of these two number is 3.99 modulus and e to the power minus 1 point something minus 1.894. Okay, let me take even 4 significant figure to make it more accurate. 894 and multiply with I. Normally we take 3 significant figure, okay, and then multiply with the e in the front to the power 3ti, and we take the real part of this complex number there. Now the next step is very simple. We just need to combine the two terms e and e, huh? So that the real part of 3.99 e to the power of 3t minus 1.894 I. Okay, so this is the answer, which means sorry, one more step to get the answer, which means that we need to convert this exponent form into the normal form of a total voltage Vt, huh? So Vt we can understand is as this modulus, which is the maximum voltage. 3.99 here is the maximum total voltage, okay, and cosine of 3t, the time variable, minus 1.894. This is the final answer. Normally we take 366, so I will remove the number 4 here, okay. So the solution to this question A is very simple like that. Just use the calculator to add the two complex number in the exponent form. And we also got the answer for the question B. The maximum voltage is 3.99 volt. Okay. Now I would like to move on to a second method that we can add these two complex number and voltages. But this second method is not recommended because it is more complicated. That method is to convert the exponent form of the complex numbers into the trigonomical form, cosine of something and add it with cosine of other things. Okay, the second method, we will represent V1 as the cosine function, which is 2, the maximum voltage of V1 times cosine of 3t. Okay, and V2 similarly, the maximum is 5, the number 5 here, 5 times cosine of 3t plus 4 here, huh? Okay, now we can use the calculator to find the sum of V1 and V2. Vt, the total, huh? The sum of V1 and V2 will be found by using the graphing function on the calculator. We will go to the menu graph and then enter the function here, huh? Let me enter it again, which is 2 times cosine of 3t. We can use the variable x here to represent t. Okay, 3x there, and then simply add the second function V2, 5 times cosine of 3x, huh? And plus 4 there. 4 closing bracket there. We just completed entering the function, the sum, the two trigonometrical function in the calculator. Now simply just click the draw function to draw the graph here. We have the graph of the trig function. Of course, sometimes we need to change the window display so that the graph looks beautiful, like it shows clearly with the maximum, minimum, the whole function display on the screen. Okay. Now we need to find two things, actually three things. A, or Vmax, the amplitude, let's call Vmax here, huh? The amplitude of the total voltage, then cosine of Bt plus a constant C. To do that, firstly, the Vmax is very easy to be found. We will find the maximum value on this function. Click on the solve here, solving, and then choose the maximum, and it would display the maximum as 3.99 there, 3.99. You see that it is exactly the same with the value maximum that we found using the method 1, huh? And now to find B, the coefficient in front of the time variable, we need to determine the period of this function. To find the period, again we go to the solve function and choose calculate the x value when y is 0, which means that I am determining the two values of x where the function is 0. Okay, choose the x calculation here, enter value y to be 0 there. So I'll see that the first value that the function is 0, the voltage is 0, is x equal 0.1078. Okay, let me write that thing. We had one value of x for the voltage to be 0, Vt equal to 0 when the time of our is our variable 0.1078. That is the first solution. And the second solution, similarly, on the calculator, we simply just need to hit the arrow button to move on to the next 0. But I do not choose the 0 here in the middle because that is only half the period. But I choose the next one right here, which is 2.202, huh? 2.202, 465, right? Yeah. So that the difference between T1 and T2, again, T1 here is like the starting point, starting from 0, the function, huh? And then at T2 here, 2.2 seconds, it returns to that point, which means the period is the difference between these two numbers, T2 minus T1, 2.2 minus 0.1078, huh? Okay, 2.202 minus 0.1078 there. So this is the period 2.0942, 2.0942 second, the period. And if you remember in the trig topic, the value b here, it will be found by taking 2 pi, which is the period of a normal cosine function, cosine of t. The period is 2 pi, huh? 2 pi divided by 2.0942 to get the value b, huh? Which means this time the period is 2 pi divided by b, huh? And therefore b is 2 pi divided by 2.09 divided by 2.0942, and we get, you see, a very beautiful number, number 3, which is exactly the same with the two number 3 here, 3t, v1 and v2. They have the same period, and therefore the sum of those two alternating voltages v1 and v2 must have the same period, and therefore the coefficient b here must be 3, which indicates that our approach in the second method here is correct. Okay, and lastly, to find c, the value c, which is horizontal, the shape of the function. To find the shape of the function, I will locate the time at which the function is maximum. A normal function, a cosine function, start from maximum here and goes down to 0 and goes up like this. It starts from 0. But our function here does not start from maximum. The maximum is not when the time is 0, but sometime here. So I need to find that point, the first time when the voltage is maximum. Now go to the solve function and find the maximum. There, the first maximum is when the time t is 0.6314. Okay, the voltage, we will find C, the voltage t is maximum when the time is 0.63 something, 6314 second. Substitute into this equation. The voltage is maximum when the cosine is 0, which means cosine of bt minus c is maximum, which is 1, when the time there is 0.6314, and the value b here is 3 that we found here. Okay, cosine of this thing minus c, a constant c, is equal to 1, which means this whole thing, the angle behind the cosine, this whole angle must be 0 degree, 0 radian, and therefore c is the product of these two things. This thing is a simple linear function, so it looks very familiar, right? C is simply 3 multiplied with 0.6314, which is 1.894. You see, it is exactly the same with the value that we found in the method 1 using the exponential form. But again, the method 2 is kind of long and complicated and not necessary. I just want to show you that we can do a lot of things very quickly if we practice with the function on the calculators. Okay, thank you for watching the video, and if you have any question, please leave a comment in the comment box below. Thank you very much.